let's work the example that we had before. We are given now the values of the resistors. R1 is 10 ohms, R2 is 20, R3 and R4 are 30 ohms, R5 is 10 ohms. So before proceeding, I need to quickly find what R534 is. Remember, R3, R4, and R5 are like this. Now, R3 and R4 are in parallel, so I'm going to calculate quickly. 1 over R34 is equal 1 over R3 plus 1 over R4. And since R3 and R4 are the same, so this is going to be 2 over R3. And R34 is just simply half of R3, which is going to be 15 ohms. Okay, so using these values. Now the next thing is R534. R534 is equal to R34 plus R5. R5 is, here is given 10 ohms plus 15 ohms, so it's going to be 25 ohms. Okay, so this is a calculation we needed to make sure we can solve for our circuit correctly. So here I'm adding R534 is 25 ohms. Okay, now this is my circuit. We are going to apply what we have discussed. I'm going to, essentially, most of what we are going to do is a repeat. Assign directions to the currents. So this is my I1. Just to make things more fun, I'm going to change the directions, the direction of I3, just to show that it's not going to matter really what we do. So this is I2, and this is I3. Now, under this configuration, I need to write my pluses and minuses. I'm going to use the red color for this. So this is my minus, plus, plus, minus, plus, minus, and I3 is coming in from the left of R34, so plus, minus, minus, plus, and minus, plus. The next step is to write the voltage drop across each resistor. For this one, it's going to be R1, I1. For this one, it's R2, I2. And for this one, it's R534, I3. Okay, so we are set. The next step is to write Kirchhoff's voltage rules and Kirchhoff's junction rule. Okay, now I'm going to take the yellow color, start here, and take this loop. So for that loop, I'm going to add up the voltages. Actually, let's do it in color like we did in the past. So starting at this point, the first thing I meet is the negative of E1. We go from negative to positive, so plus E1. Then from here, we meet the positive of R1. So we are going from positive to negative, so that's minus R1, I1. And then we go here and we meet the negative of R2. So we go from negative to positive, so that's plus R2, I2. And then we meet the positive of E2, and we go to the negative, so we are dropping an electrical potential, so it's minus E2. And we are back to where we started, so this is equal to 0. That's my first loop equation. Okay, I'm going to try to erase what I just did. Okay, and I'm going to do the same thing now for another loop. There are 3 possible loops I can make. There is that loop, and the big loop doing the outside, kind of starting where we started, E1, R1, and then E3 and R534. or the loop to the right that I'm going to do right now. I'm going to choose the loop to the right. Again, go in yellow. I'm going to start here, and I'm going to go around like this. So again, choosing a different color. Now as I start here, the first thing I meet is the negative of R534. So it's going to be plus R534 I3, since I go from negative to positive. And then I meet the negative of E2, so that's plus E2. And then I meet the positive of R2, so that's minus R2I2, since I go from positive to negative. And then positive of E3, so it's minus E3. And I'm back to where I started, so this is equal to 0. So that's my second loop equation. And I need to write as many equations as I have unknowns. I have here I1, I2, and I3. 3 unknowns, so I need 3 equations. So I have 2 loop equations. The other equation I'm going to write is the junction rule. Now the junction rule, okay, let's write it in red. So I have I1 here, I have I2 here, and I3 here. All of them are pointing towards that junction. So for that junction, the sum of I in is equal to the sum of I out. In this case, all of them are coming in, so I1 plus I2 plus I3, and there is nothing coming out, so that should be equal to 0. I purposely chose I3 coming in to show you that we can do that. Okay, we are set with our equations. The rest is going to be math. So what I'm going to do next is rewrite these equations with the values that we know. The last equation that I just wrote, we don't know any value. But the top one, I'm going to rewrite it, just squeeze in the space just below where it is. We know what E1 is, so that's plus 10 volts. We know what R1 is, so it's minus 10 ohms I1. And then we know what R2 is, so that's going to be plus 20 ohms I2. And then we know what E2 is. Actually, this is meant to say E2 is equal to E3 is equal to 20 volts. So there is a typo there, but it's minus E2, so it's minus 20 volts is equal to 0. So that's our first equation. Now for our second equation, I'm going to use the green color to write it. Okay, so R534, that's 25 ohms. So 25 ohms I3. And then plus E2, so that's plus 20 volts. And then minus R2I2, so that's minus R2, which is 20 ohms I2. And then minus E3, which is minus 20 volts, is equal to 0. And we have the red equation. That does not change. We don't know anything else in it, so that's the way it looks. So we have 3 equations. I'm going to try to highlight them here. First equation is this one. Second equation is this one. And the third equation is this one. 3 equations with 3 unknowns. Of course, we will need to find the currents through R3 and R4, but we can do that in an added step. Now, so these equations, to be able to solve them, it would help to write them next to each other cleanly. So the top one, we can combine the plus 10 volts to the minus 20 volts. That will give us minus 10 volts. And the equation becomes minus 10 ohms I1 plus 20 ohms I2 minus 10 volts is equal to 0. The second equation is just I1 plus I2 plus I3 is equal to 0. And the third equation is 25 ohms I3, and then the 20 volts combined with the minus 20 volts, so it disappears, minus 20 ohms I2 is equal to 0. These are my three equations. I'm going to erase what's on top just to have the space to write without having to go to another screen. Okay, the last equation gives us a simple relationship between I1 and I3. So actually, if we rewrite it, we have 25 ohms times I3 is equal to 20 ohms times I2, which gives me I3 is equal 20 over 25, so 4/5 of I2. So that's one thing. Now, so in this case, it's an easy thing. I was able to find a relationship between two equations. What I can do next is replace I2 here in the first equation by what I found here. Remember, I can write this as well as I2 is equal to 5 over 4 I3. So I can do that here in the top equation. So I have minus 10 ohm I1 plus 20 ohms times I2, which is 5/4 of I3, minus 10 volts is equal to 0. And I can replace I2 in the second equation. So I have I1 plus 5/4 of I3 plus I3 is equal to 0. So now, instead of three unknowns, we have a relationship between I3 and I2. But I have two equations with two unknowns. I'm going to use a different color for writing right now. I'm going to, let's go to black. So the top equation, if I would like to clean it up a little bit, I'm going to divide everything by 10 ohms. When I divide everything by 10 ohms, this one is going to become minus I1. Okay, so this equation is going to be here, minus I1. And then 20 ohms over 10 ohms, that's 2. 2 times 5 over 4, that's 10 over 4. So it's going to be plus 2.5 I3. Over 10 is 2. 2 times 5, 10. 10 over 4, 2.5. That's the way we got the 2.5. And then minus 10 volts over 10. 10 volts over 10 is 1, but it is 1 amp. So minus 1 amp is equal to 0. That's my top equation. And my second equation, what I have here, 5/4 of I3 plus I3. So it's 5/4 plus 4/4. So I have I1 plus 9/4 of I3 is equal to 0. That means I1 is equal to minus 9/4 of I3. That's my second equation relating the currents. Now, if I take this I1 and place it on this equation here, I'm going to write it in color. Let's go red. So now what we have, minus 9/4 of I3 plus 2.5 I3, and I'm going to move the 1 amp to the other side. It's equal to 1 amp. Minus minus is plus. So I have 9/4 plus 10/4, so it's 19/4. So essentially I have to work this out. So I3 in this case is going to be 4 over 19 amps. That's about 0.21 amps. Now, to find I2, all what I have to do is use this equation. So I2 is going to be 5 I3 over 4. So that's going to be 0.21 times 5 over 4. So I2 is 0.26 amps. And I1 is minus 9I3 over 4. So it's 0.21 times minus 9 divided by 4, which is I1 is then minus 0.47. Okay, that's my currents. So I'm going to write it in the next screen. So we said I1 is minus 0.47 amps. I3 is 0.21 amps. And I2 is 0.26 amps. Okay, that's correct. Now here the last thing is to find the currents through R3 and R4. Through R5 it's the same I3, we don't have to worry about it. But since R3 and R4 are the same right now, we just know that each one of them is going to carry half of I3. So I4 is equal to I5. It's going to be I3 over 2, which is going to be 0.10 amps. Now, if the resistors were not the same, what we would have had to find is the voltage across R34, and that voltage is going to be R34 times I3. Once I find that voltage, I4 is going to be equal to VR34 over R4, and I5 is going to be equal to VR34 over R5. And that does it for this question. Okay, it's not as bad as it looked.